In this tutorial, we are going to look at the other half of flow control, which is branching. Along with branching, to really understand it, we are also going to look at some basic mathematical operations in Unreal, and we're going to look at something more importantly called conditionals. So let me just start by showing us the basic branch node in Unreal. Again, back in my test blueprint, which is empty, I'm going to right click and I'm just going to search branch. We can see, again, under flow control, there is an option called branch. Let's add it. A branch has two output execution pins, one true and one false. So depending on the value of its one input data pin, which is condition, which as we can see is a Boolean, it can be either true or false. If the value of the condition is true when we run our branch, it is going to run through this true section. If the value is false, it is going to run through this false section. So let's just quickly see that in action. I'm going to add a print string. I'm going to call this print string true. I'm going to make sure I set the duration to something big just so that we can all see it. And then I'm just going to copy and paste it and make one for false. Plug the false into false, true into true. So if this condition variable was false, we're going to run the false execution, and so it's just going to print false. If our condition were true, on the other hand, it's going to run the true execution, which will print true. So right now condition is true. When we run this and we run play, you can see that it prints true because our condition was true. If I change this to false and do the exact same thing, you can see it prints false. That should be fairly simple to understand. But conditions on its own are kind of hard to use, so we use something called conditionals. So let me just pull up Paint here and let's just talk about conditionals for a bit. You may have learned this in math when you were in school, but there's three basic conditional operators. You have less than, you have greater than, and we have equals to. We can combine equals to with less than, for example, to make less than equals to, and we can combine equals with greater than to make greater than equals to. So these are the three basic types of conditions we can have. So if I was just to take two random variables, let me just call it x and y, we can say things like x is less than y, or x is less than equals to y, or maybe x is equal to y, and these conditionals can help us evaluate into a Boolean. So for example, if x was equal to 10 and y was equal to 5, we can evaluate this. X is less than y. X is 10, y is 5, 10 is not less than 5, so this would be false. X is less than or equal to y. Well, x is much greater than y because x is 10, y is 5, so x is not less than or equal to y. This will also be false. Same thing with x is equal to y, 10 is not equal to 5. This is also false. If we had said something like x is greater than y, 10 is greater than y, so this would be true. So this is one way of thinking about how conditionals can be used for branching. One use of this in games, probably the most common one, is our health. If our health maximum is 100 and we are dead when our health is 0, we can always test, is health greater than or equal to 0? So every time the player takes damage, we test this variable, or we test this conditional. If it's true, then the player is dead. If it's false, they are not dead. They can continue playing. Along with these basic conditionals, we have a couple of operators that we can use to help improve our logic. These would be and, or, and not. We can combine these with our conditionals to create some more complicated conditions. So I could say something like x is less than y and x is less than z. So I'm just going to make a new variable here called z and tell you that it's 3. So x is less than y, we know that 10 is not less than 5, so this is false. And x is less than z, 10 is not less than 3, so this is also false. So if this is false and this is false, our output is also going to be false. So just like that, we can use these and, or, and not to create slightly more complicated chains of conditionals. The and will only evaluate to true if both sides of this equation are true, or will evaluate to true if either side of the equation is true, and not is just going to flip whatever we have over. So if I had x less than y, but I said not x less than y, we know that x less than y is false, and not false is really just true. So one use of not, for example, again, when we think about our health, instead of saying is health greater than or equal to 0, I can just say health not equal to 0. So when the health is equal to 0, we know that the player should be dead. If the health is not equal to 0, we can just continue running the game. All of these operators can be combined in different ways to do the same things. It really just depends on how your thought process goes when doing it. But it's good to know that the types of things we can do is greater than, less than, equals to. We can combine them to make greater than equals to or less than or equal to. And finally, we can combine these things even further using and, or not. Real quick, in Unreal, let's just go and see these nodes kind of in action. In our palette, all we have to type is the greater than symbol, and you can see under operators we have, or I'm sorry, this was less than, but under operators we have less than or less than equals to. We can type the greater than symbol. Same thing. If I type equals to, you have equals to as well as the combinations of equals to. The other thing we can type is something like and. And if I scroll all the way down, you can see and Boolean. And all this does is take two Boolean values and output another Boolean based on the and condition. We can plug that in here just to see it in action. So if I only check one of these ands on and I run it, it's just going to print false. However, if both of these ands were true and I was to print it, it prints true. One good use case for and thinking about it is if we have 3 keys in the level, for example, so I can add another pin. If my player had if they had all 3 keys, would the final door open? That is where this and could come in handy, because if they have only one of the keys, it's not going to work. They need specifically all these to be true for it to run. So just looking at conditionals again real quick, let me just show you one of these conditional nodes. You can see that it takes 2 inputs. It can take inputs of various kinds. We can compare not only integers, we can also compare floats, and we can also compare vectors. And the output, more importantly, is a Boolean. So if I was just to make another new variable, I'll call it x, and I'm going to change this current new var to y. These two are both integers. So let's just set it to what we did in our paint. X is 10, and y is going to be 5. Let's get these variables out here. And so here we are doing is whatever on top less than whatever is on the bottom. So let's check if x is less than y. X is 10, y is 5. We expect this to be false because 10 is not less than 5. I run it. It says false. If, however, I were to come here and switch these around, so now we're comparing y to x, is 5 less than 10? Yes, it is. So when we run this, we see that it's true. So this is just a short run through of how we could use conditionals and simple variables as well as Boolean nodes to help create some logical flow in our program. This is part of the decision making that our program can do. It'll only do things when certain conditions are true. It'll do other things when these conditions are false. And this becomes very useful in our gameplay programming. We are going to start seeing this all over the place. Thank you for watching.